This next subject in math, trigonometry, is also essential for this course. This will be section 44.9. And trigonometry, or trig as it's often abbreviated, has to do with angles and in triangles and the ratios of those sides. The origin of trigonometry is basically that if I have two similar triangles, I'm going to draw two similar triangles here. And if this is an angle theta, if this whole distance is a distance x1, and this is a distance x2, and this is a distance y1, this is a distance y2, then you can see that y2 is to x2 as y1 is to x1. Simply because of the ratio of the similar sides of two similar triangles, because they have the same area, same angle, theta. And they're both right angles here, so the triangles are similar. And it's also kind of obvious that those ratios would hold. Therefore, those ratios of all the triangles, you can imagine 1,000 different triangles, all of those have the same ratios, and therefore they're characterized by the angle theta, which can be used to characterize the ratios. What is that angle? It turns out to be the tangent of the angle theta. We call this the tangent of the angle when it's the opposite over the adjacent. Well, what are all of these different ratios and how do we define them? If we have our basic triangle, and let's write this as y, x, and r, then in fact we define the sine of theta by definition as the ratio for a triangle that's a right triangle with these three sides is the opposite side y divided by r, the hypotenuse. And we define the cosine of theta to be the adjacent side, x, divided by r. We define the tangent of the angle theta to be y over x. And if we solve this equation for x and this equation for y, we can see that y is equal to r sine theta. And x is equal to r cosine theta. We can cancel the r's, and therefore the tangent of an angle is equal to the ratio of the sine to the cosine. There are many trigonometric identities, and that's one of the things you study in trigonometry. This is one of them right here. Another one is the fact that the cosine squared of theta, cosine squared minus sine squared. I have that here somewhere. So cosine squared plus sine squared of theta is equal to 1. And that basically comes from looking at the Pythagorean theorem and the fact that x squared plus y squared is going to be equal to r squared. And if I want to take that, I can prove it. I can solve this for x and solve this for y. And when I do that, I'll say x is equal to r cosine theta. And I'm going to take x squared and add it to y squared and get r squared, which you already know from the Pythagorean theorem. So y, if I take y, it would be r sine theta. So I square it, square this, and what do I get? I get r squared times cosine theta plus r squared times sine theta must equal to r squared. I can cancel the r squareds then and get 1, proving that the cosine and the sine when squared equal to 1. The hyperbolic functions are just the opposite, and we'll find that out later when we look at the cosine, the hyperbolic cosine squared minus the hyperbolic sine squared is 1. So you should go back and review your trigonometric identities and be very comfortable with that. So what is x here? If we take a triangle and use real numbers, then let's say if we use 30 degrees, it turns out that the sine of 30 is equal to 1/2. And if the sine of 30 is equal to 1/2, then we can write x. Let's see, this is x and this is y. If we want to know what y is, we can say y over r is equal to sine theta. So therefore y is equal to r sine theta. If r is equal to 6, and we know that our angle is 30 degrees, the sine of 30 degrees is 1/2. So in fact, we would have that this was equal to 6 times 1/2, 0.5, so it's 3. So this would be 3. Also, you can play around with that some more. You can say, well, if I know these two sides of the triangle, if I know 3 and 6, what's the other side? Well, I know that 6 squared is going to equal to 3 squared plus the other one, x squared, and solve that very quickly for x squared. So what do you have to do for this course? You have to be familiar with the type of work that I'm doing here. You have to be able to move relatively rapidly in figuring out how I do trigonometry in the sense of very simple angles. If I know the radius or if I know one other of the sides, how I find other things.